colon. Okay, so this week we introducing this rational expression. Before talking about rational expression, we're talking about factor. Factor. Factor, actually, we finished this kinds of earlier progress to how to get a factor, and then introducing, just like we introducing this factor earlier, we only talked about is the number factor, right? And then we talked about the polynomial factor. We introducing what? We say something like, say 56 can separate into 8 times 7. And then we say introducing the x, this kind of 7x, this is actually two factor here, right? And then we introducing into the polynomial. Very complicated cases, like say ax squared plus bx plus c. And then factor into a, like this. And sometimes even have some factor in front, coefficient in front. And right now we finish this part. We move into fraction. With fraction. This is whole numbers. When they move to the fraction, what do they change? They made of like this. It's numerator, right? Denominator and numerator. Is it correct? Right? Like say, give example. These kinds of fraction. So earlier is number is called ratio, right? You also call ratio. Fraction like this one, you also can say call ratio, and you can transfer percentage, right? You can transfer into decimals. This is you learn from the 3rd grade, 4th grade, and 6th grade, right? And right now, in the pre-algebra, you introduce into like this kinds of basic fraction. That you still need to use the concept about ratio, percentage, and decimals. And then build something like equations. And you can get the answers out of here, right? This is what you learned earlier, right? So you can say x got 80 here, right? So right now we move this a little bit further. Since we're introducing polynomials, we make a fraction a little bit further, like this one. Right now we focus a little bit further, like saying this expression is not only its number, it's not only one variable. We want to make it a polynomial, just like the numerator and denominator, both made of these kinds of polynomials. We call this is called rational expression, right? Of course, this expression can be constant numbers, also can be just only one terms. But some cases will be made more complicated is they are polynomial. They are go up to 3 or 4 terms. And this is the numerator, right? Numerator. And this is the denominator. All right, denominator, numerator. So we call rational expression. Right? So you can see this is actually still a fraction. They made of denominator and numerator. Only thing change is this kinds of numerator and denominator is more complicated. They are made of polynomials. All right. All right. So see some examples. Let's see some examples. All right. Some examples. So this kind of concept is rational expression. Actually, they still like the fraction. They made a numerator and denominator, two parts. Okay, something like this one. Something like this one, A. So in the fraction, same to the in the fraction. When they are denominator, this is denominator, right? They cannot equal 0. So in this kind of rational expression, the same to fraction, their denominator cannot be 0. So when they should be defined. It means when they are equal 0, when their denominator equals 0, means this fraction is not make sense, right? They made of the numerator, denominator cannot be 0. When they become 0, it's undefined. When the denominator, they cannot equal 0, right? When they equal 0, when they are not equal 0 was defined. When the denominator is equal 0 is undefined. Undefined. So first thing, we need to make sure that denominator cannot be equal 0. When they are equal 0 is undefined. So one of the quick question here, some less several rational expression here. You can see they made of the numerator and denominator, right? So we want to find out if they are defined or not, if they are defined or undefined. When they are undefined, it means their denominator is equal 0. So like this expression, the denominator is the bottom part over here, right? So when x minus 3 equals 0, this expression is undefined. So let's see the example here. Are there any value for x for each of the rational expression is undefined? So actually it means you try to find out their denominators when they become 0. So for the example A here, actually the denominator is x minus 3, right? So when they become 0, they are undefined. So x equals 3. So x equals 3 make this undefined. So x actually should not equal negative 3. Should not equal 3, right? Right. In the second, this kind of rational expression, the denominator is right here, right? It's the bottom part of this long line fraction. So when they became undefined, so it means the denominator became 0. What this means? Yeah, we go back to our journal again, try to factor in, right? Build this equation. So we need to use previous knowledge. Right? So you got what? 3x. Oh, something wrong here, right? Here it should be minus 2 minus 1. Should do like this. 3x squared, negative 3, negative 2, so positive 2. So you got here. So one of the solution here is 2 over 3. Second solution is 1. So when x equal 2 over 3, or the other one is 1, they would make this denominator become 0. So when it's 0, this rational expression is undefined. Undefined. The third one, obviously, they are given a constant number here, so they're never undefined, right? They always not equal, they never equal 0 because of they define denominator is 3. For the fourth, this d, x squared plus 1. Is it possibly equal 0? Not, right? Because of x squared always greater equal 0. This is a positive number or 0 and plus 1. So it means this one never is greater or equal than 1. The whole of this one is greater or equal than 1, right? So never equal 0. So there's no undefined situation for this part, for the D. So there's no answer for C and no answer for the D. So any numbers, whenever you put x squared plus 1 greater or equal than 1, right? So their least denominator never get 0. All right. So see, quick question here. You can see practice here. So see the A, this kinds of rational expression. Any layer, any values of x for which the rational expression is undefined. So the same here. So x plus 6 will equal 0, they will be undefined, right? This one is not available. Any number cannot make this denominator become 0. The third expression, so we can make this denominator become 0. So we can use the factor methods we learned earlier, right? So you got when the x equal -2 or x equal -4, they make this denominator become 0. So x should not equal -2, x should not equal -4. For the fourth one, similarly like here, any number power 4, they always greater or equal than 0. So this denominator always greater or equal than 5, right? So there's no number can make this denominator rational expression undefined. So any rational expression, make sure they are reasonable. We should make their denominator not equal 0. That's the first. This means at least it need to be defined like the fraction, A always not equal 0, right? The same. All right. So let's go next one. So when we know rational expression is defined, make the denominator not equal 0. We try to make it simplified. Some very complicated cases will make it simplified, right? Something like, say, earlier you guys definitely learned like this, 24 over 32. So this is fraction, they can simplify. How they simplify them? You say this is 3 times 8, this is 4 times 8. So 8 is their common factor. They can get rid of them, right? If they are not equal 0. So you can simplify into like this, right? This is the progress. Just like earlier, what are you learning about a fraction? They can be simplified. So exactly the same like rational expression. So what I'm telling you here is you consider rational expression exactly like fraction. They can do the same, they needed to do the same operation like the fraction. So they can be simplified. All right, let's see some example here. First, like the example. So you can see this one actually made the numerator and denominator. The numerator, they can factor, right? And denominator, you can see this is x squared, x minus 1. Right? So you can simplify. X cannot equal what? And x cannot equal 0, right? X cannot equal 1. Keep this in your mind first. You need to be, this one need to be defined. So the denominator part cannot equal 0. So it means x cannot equal 0, x cannot equal 1. After that, so this one is not 0. You can factoring out. So you got a 5 over x squared. So you can simplify, right? Like this one. So you take x, like this expression, the numerator part, you can factor them like this. And denominator, you can take 6 out, x minus 1. Keep in mind, x not equal 1 first. make sure this expression is makes sense. And then you can simplify them. Right? All right, so see, you go more simply complicated case, like this one. So the numerator top part, so x, you can factor them, right? We learned this one, so we use them very frequently about a fraction. What about the bottom? Right, so you can see x cannot equal 5, x cannot equal -1. Keep this in mind. So after that, you can use this same factor, x plus 1, x plus 1 is same factor, can be factored out. So you can simplify them, right? Like this. But keep this in mind, they have cannot equal 5 and -1. More example, like this rational expression. The numerator, actually, you can see is x plus 2 squared. The bottom part, like this, right? So x cannot equal 0. X cannot equal -2. After that, you factor one of the x plus 2 out. So the top part is only 1x plus 2, right? The bottom is x. Okay, sounds good. See, we see more examples like this rational expression. So the bottom denominator, so we can do what? 3x is -2 plus 1x. Let's check it. That's 3x squared, -6, +1, -2, right? So you can get factor. Based on factor, so what about the numerator? Numerator will take it negative out first. The rest x squared -4, right? So you can factor into x plus 2x minus 2. So x cannot equal what? -1/3, right? X cannot equal 2. So make sure the bottom part makes sense, defined first. And then we factor this out. Right? So you got a -x plus 2/3x plus 1. All right. See more example like here. Same progress, right? The bottom denominator. So x cannot equal -9, right? First, the top part. Right? All right. So x cannot equal -9. We can factor one of the x plus 9 out. So you can get x plus 9 in the denominator, and the x squared in the top. Okay, so simplify is easy. Just like this progress, you guys learned this before. Okay. Since we know this one, we do the same for the other progress. Fraction, they also have the what? Multiply. All right, so we need you guys to think about earlier when you do the numbers like 3/4 times 7/9. How you do that? When you do the multiply, the numerator times numerator, denominator times denominator, right? Is it correct? Like A times over B times C over D, you got A times C, B over D, right? For the fraction part, right? So you got it here. So after that, this became rational expression. You also can simplify it and then make it more simplified case, right? Okay, so actually here you use the P over Q, R over S, the same as what I'm talking about here. So when the two rational expression, suppose here is one fraction times another fraction, just like this is one rational expression times another rational expression. So the new denominator part and numerator part, they time together, they product together, right? So after that, they do the simplify. So the progress is writing here. Step 1, complete the factor numerator and denominator. completely. You can factor it first, make it simplify first if they are too complicated. A multi-numerator, a multi-denominator. And the third step, simplify the expression to the lowest, make it more simplified version, right? Okay, so you can get this one. Something like here is one expression, next expression. So actually you can get a 2y cubic and right? Like B cases. Here you can get this is one rational expression, second rational expression, right? So first we can begin a numerator, but we can just link this together, and bottom part is time together, right? That became two factors, and then we simplified it. Factor this a squared out, factor one of the y out here became 4, 5 became 4, right? We can 7 factor 14, which here became 2. So here -3 over 10, what top part is y over 4, the bottom part, nothing, right? So let's see, that's this one. So let's go a little bit complicated case, like this one. So this is one of the rational expression, right? This is second expression. So first we can factor them first, okay, and then time them together. 3x times 5x plus 1, right? We factor them. This part we can factor 5. So x plus, so keep this in mind. X cannot equal 0, x cannot equal -1, right? So x plus 1 is a common factor, factor out. X is common factor, factor out. After further, so you got a 2 over 5. See, it's easy, right? It's easy. Okay, let's see the second example here. So top one, we first factor them completely in time 15. What's the bottom part? 5x. What about the right part? Here can factor into x plus 1, x minus 1, right? So keep this in mind, just like x cannot equal 0, x cannot equal -1, x cannot equal +1. So after that, you can factor the common factor out, right? So here equal 3. So it became 3 over x plus 1. Right. Let's move on more complicated case. So here, so you can get is what? So you can factor them completely. Here became 3, right? X plus 1, right? For this is rational expression. The bottom one is 5. We can take x out as well. We can take -1 out, -5 out. So x minus 1. Sounds good? So like this one, you take a -5x out. Became x minus 1, right? What about right part? Right part here is 2x minus 1 plus 3x. 2x squared, -2, 3x. So you got x, right? -3. Bottom part, 2x plus 3, 2x minus 3, right? You can begin 2x squared minus 3x squared, right? So you can use the special product progress. So keep this in mind. X cannot equal 0. X cannot equal +1. X cannot equal what? -3 over 2, and cannot equal +3 over 2. So this is from the denominator part. So after that, what we can factor of? 2x plus 3, 2x plus 3, x minus 1, x minus 1. Right? After that, nothing can be factored away. So we just copy the left part. It's 5x, -5x, and 2x plus 3, minus 3. Right? Same for the last example here. So first we factor in completely. We take a -3 out, okay? So x minus 2, right? So take a 6x out. Here's x plus 1. So time, like the numerator part, is time together, right? So bottom part, let's begin bottom part first. What about top part? 3x minus 5, right? X plus 1. Check it. 3x squared, positive, -5. So you got a -2x, -5. So again, just write down here, x cannot equal 0, x cannot equal -1, x cannot equal -2, and x cannot equal +2. We come from here, right? All right, so after that, you can say factor the common factor out, right? Just like you factor these kinds of progress, this common factor can be factored out, right? So the left, right? So the left here is -3x minus 5. What about the bottom part? 2x plus 2. That's it. That's it. So we can do the multiply. We also can do the divide. We also can do the divide, right? We also can do the divide. How we do the divide? When A over B divide C over D, what do we do change? When it became, when this divide became times, this part of flip reverse, right? We can reverse, right? And after that, it became multiply, right? So it became A times D, B times C. Is it correct? So do the additional step actually. When they do divide, this, the second of the rational expression need to be reversed. And then do the progress, same progress as before. All right, so let's give one example here. So first, you need to change this one to the times, right? So we can do we do this progress to here directly. So first, we here equals 2 5x minus 1. We first see the first expression first. We factor them first. See the second expression. So we reverse, right? We reverse this one, right? So x plus 3, this denominator became numerator. The numerator became denominator. At the same time, we factor it. Did you see this one became reverse? Reverse then. X plus 3 became top. This one became a denominator. And then we can just time them. We link them together, right? And then we do the factor. 5 minus 1, 5x minus 1, x plus 3, x plus 3. Just keep this in mind. X cannot equal x minus 3. X cannot equal 0. X cannot equal 1 over 5. All right. And then finally left is 2. The bottom is x plus x minus 3 actually. Right. So let's see. So reverse divide actually is just reverse the progress. I mean, reverse the second denominator, second rational expression. Okay, let's do the last example here. And then we end for today's topic. So first, for this one, we factor first expression. This one we can change into what? 3x minus 4 minus 1 x, so x plus, so 3x plus 1 x minus 4. So we check it. So they are correct, right? X minus 4. Second one, we change this divide into positive, into times, right? So the rest was keep changing here. This top is 6. The bottom, we put a numerator, became a denominator, right? So x cannot equal 4, right? X cannot equal -3 over 1. from, I'm sorry, yeah, can do the same, cannot from here. So right now we factor them. 3x plus 1, 3x plus 1 here, a here gone, 2 is gone, so equal 1. Equal 1, right? All right. So that's all for today. That's all for today, everyone. Thank you all. Any questions? Any questions?
No.
Okay. So I will send the homework a little bit later today or tomorrow. All right. See, so have 2-week break. See you the week after 2 weeks. Have a wonderful spring break. See you later.
Thank you. Bye.
Thank you.
Bye-bye.